I want to thank everybody for joining today. We have a mechanical hangout with Suop Ozil. He's the product manager for Simulation Mechanical, and we invited him today to talk about the 2015 R1 release and really talk about what's new, the latest and greatest, all that sort of great stuff. So I hope everyone that is in attendance is looking forward to this. I think it will be a really good time for you to ask questions to our product manager. So please ask questions in the question window throughout the presentation, and we'll feed those questions to Suop so that he can respond. But before we get going, I do have 2 poll questions. They'll be quick and easy. The first one is, which analysis types do you typically use when you do mechanical analysis? You can pick as many that apply. Not surprisingly, 90% of you do linear static stress, followed by nonlinear, about 80% of the attendees, and then about 50% for linear dynamic, and about 35% for thermal, and then there's a few of you out there that do electrostatics. Okay, thanks for that first poll question. We'll go on to the next one. Now, if you do perform in linear dynamic, which do you use? Frequent response, random vibration, response spectrum, or transient stress? Frequency response is off to the early lead, above 90% of everyone that's attending, and followed by transient with about 60, response spectrum at 45, and random vibration at about 30-something. Some people are still voting, so I'll let that go a little longer. Excellent. I'll close that. Thank you, everybody, for responding to the polls. Okay, at this time, I'm going to pass it over to Suop. And remember, if you have questions, open up the question window, type those in, and we'll do our best to respond to those questions. Thank you.
Hi, everybody. This is Suop Ozil. I'm the product manager for Autodesk Simulation Mechanical. You may have seen me on different forums, including the Autodesk forum as well as the LinkedIn user group. I also try to stay active on SimTV by recording most of these sessions so that you can go watch it on your own time as well. And today I wanted to join this group and do a live version of the similar presentation I've done on SimTV on what's new in Simulation Mechanical 2015 R1, and also be able to take questions from you guys. So that's probably the more important part for me, is to be able to take questions and answer some of those. I also have the software installed on my computer, so in addition to the PowerPoint, we can dive into the software to highlight some of this new stuff. Probably during the Q&A session in the second half of the presentation. So let's get going. Before I start talking about all the new features and enhancements, I just want to give you guys a timeline as to what happened basically since January in terms of our releases. At Autodesk, we try to do one major release every year. Especially in the simulation department, we line up all of those releases on the same day. So back in April, we released the 2015 release. That was, I believe, April 9. And typically, we would wait another year and release the next release on the upcoming April for the 2016 release. But in this year, we've changed things around a little bit and did a couple additional releases mid-year. So the first one we did was back in June, and on June 2nd we released what's called a Subscription Advantage Pack. And we posted it on the Subcenter, and for those of you who were active with your subscription, you could go and download that and basically uninstall your Simulation Mechanical 2015 and download the Subscription Pack 1 is what we called it. And that was June. That included some Nastran solver capabilities. It included the installation of the Nastran editor, and then it included a little bit of usability improvements to the Simulation Mechanical. And then I did record all of that in SimTV. If you're interested in what was in that release, you can go back and watch those videos. And then about a month or two after that, so this would be August 15 release date, was our latest and greatest, which is 2015 R1, which is what I'm showing in this presentation. So this R1 is basically a re-release of 2015, and it includes everything that was in the June release of the Subscription Advantage Pack, and then also some new additional capabilities. So that's what I'm covering in this presentation, is the latest and greatest that we released on August 15, and this is essentially a re-release of 2015 with a bunch of new features and functionality. So this also has all the Nastran solver integration work that we have done in the June release with the additional of a couple new analysis types. This has the Nastran editor in there as well for editing Nastran input decks and being able to run Nastran decks within the editor as well. We've added some new CAD data support to be able to open different types of CAD files directly. The meshing improvements that we have added in the June release are also included with the additional of per part meshing that I will highlight in a minute, and then some additional usability improvements. And there's a sub-bullet point that I didn't talk, which is about the local and cloud-enabled solving, which I will highlight in the next couple slides. So let's get into the Nastran solvers and what is included in this release with Nastran. So one of the poll questions in the beginning, we asked was about the analysis types. As you may already know, Simulation Mechanical has roughly 20 different analysis types that you can choose from. For the following 6, namely linear static stress, nonlinear static stress, modal with load stiffening, critical buckling, and steady-state thermal, in the ribbon, now you have the option to choose to run such setups using the traditional Simulation Mechanical solvers or the newly acquired NEI Nastran solvers, which are now rebranded as Autodesk Nastran. You can do this one at a time for each design scenario using the Run Simulation button, or if you access the Solver Manager, and this was a new feature in 2015 to begin with, so if you haven't used it, I highly recommend you checking this out. If you access the Solver Manager, you're going to get a new dialog that pops up and lists all the different design scenarios in your active simulation file. And you can choose your target computer to be your local machine or the cloud machine if you have the cloud-enabled version. And what's new is that we've enabled this processor section, which is going to let you choose, based on the analysis type, of course. It has to be one of these 6 analysis types. You can choose to run them using the Simulation Mechanical processors or the Nastran processors. The default processor, when you install the software, is still Simulation Mechanical. So if you want to change that so that you always want to run with the Nastran processor, you can easily do that by going into the Tools options. We have added a new tab called Processors, and within that tab, based on the analysis type, you can change your default setting to use Nastran or Simulation Mechanical. So for those of you who want to try it out, you can go into Tools options and change it. So that becomes your default, or for those of you who want to just continue using Simulation Mechanical as a default and try the Nastran solvers on one-off, you can simply use the ribbon pull-down menus. All right, let's talk a little bit about the cloud-enabled version. So for those of you who are using our perpetual licensing, this does not really impact you at all. But for those of you who are using our Simulation Flex software, and we have 2 flavors of that. One is called Autodesk Simulation Flex, which includes Simulation Mechanical, Simulation CFD, and robot structural analysis with cloud-enabled versions. For those of you who are using that package, we also did a re-release for the 2015 version in, I believe, the August 15 to 20 timeframe. I don't exactly recall the date. But this is also available, so you can go download the Autodesk Simulation Flex 2015 R1, which includes basically everything I'm showing here, as well as for those of you who have the other flavor of the Flex version, which is called Autodesk Simulation Multiflow Flex, which has Simulation Mechanical, Simulation CFD, Robot Structural, as well as Multiflow. for those of you who have this package, you can also go download the 2015 R1, which has all the new capabilities of the R1 release of Simulation Mechanical 2015. All right, so what does this give you? This gives you the capability to run those same simulations both locally as well as on the cloud, based on which target computer you choose. Of course, the benefit of the cloud is that you can solve multiple different design scenarios or multiple different simulation files simultaneously on the cloud, by using different computers on the cloud, so that you're not, waiting for one job to finish before the next one starts, which is, what you're experiencing on your local machine. All right, so let's go into some of the additional benefits that you get because you have this Nastran integration. So for those of you who are using, and these are just examples that I am highlighting here, this is not the entire list. These are the ones that I benefit from the most. So if you run a model using the Nastran solvers, you have the ability to run them using within Simulation Mechanical, or you can run them within the Nastran editor. And I'll highlight that more in the, maybe the live segments, but if you run something through the Nastran editor, and specifically, let's say, static stress, you get some additional result types that Simulation Mechanical did not give you till today. So one of them is called normalized stress error measure. Another one is contact pressure. So if you have two parts that are in contact, you can look at the pressure in between the two objects as a contour. For those of you who are doing thermal analyses, you've been asking us to integrate a result type called thermal gradient. Now this is available, so that's what you're looking at in this image right here. This is the thermal gradient for this analysis for a thermal result. So those are the type of results that comes standard with Autodesk Nastran editor. That if you just simply run your analyses in the editor, you're going to be able to get all these different types of analysis results. We're of course working on integrating those type of results into the Simulation Mechanical's results interface in future versions, but for the time being, you have access to all those within the editor. Now the next question becomes, how do I go to this Autodesk Nastran editor? So we've enabled some new workflows for these new tools. The first one is the export, right? How do I export a model? So you set up your model in Simulation Mechanical like you always do. You create your mesh, you create your loads and boundary conditions, and you can simply run them within Simulation Mechanical with a SimMech solver or a Nastran solver. Or if you want to go into what's called the Autodesk Nastran editor and run it within the editor to get those additional results, you have to export your setup, right? So what you do is you click the application button and go to the export pull-out menu and simply select Autodesk Nastran editor. And what this will do is it will check your setup. It will solid mesh if you haven't solid meshed your geometry. It will decode the geometry, convert all your loads and boundary conditions into a meaningful finite element input model. And then it will convert that input model into a Nastran format. And then it will launch the software called Autodesk Nastran Editor, and it will populate the input deck in that editor so you can immediately start looking at that exact input deck. You can edit it, meaning you can change your loads, boundary conditions if you want to, or material properties, or any type of additional settings. And when you're ready to run it, you can simply just say run simulation and look at your results within the Nastran editor. Now, this export workflow supports not only the basic 6 that we have highlighted, static stress, nonlinear, modal, load stiffening, critical buckling, steady state thermal, but we've also added the DDAM method, the dynamic design analysis method. This is for those of you who are in naval shock testing. You can export your setup to Nastran editor for these 7 analysis types. Now, for those of you who are not familiar with Nastran at all, you may not really know what you're doing, especially on day one, in terms of looking at these results in a different interface. So you may be reluctant to look at your results in the Nastran editor. So we've also enabled a workflow where you can actually bring those Nastran results into Simulation Mechanical to use our results interface to do additional standard post-processing. So that's pretty straightforward as well. All you have to do is come to this application button, click the merge, and then all you have to do is choose from the drop-down list of things you can merge into your setup file what's called a Nastran results file, which is the file extension is OP2. So you just say merge and choose an OP2 file, choose the OP2 file that the Nastran populated, and merge those results into your existing simulation FEM file. All right. Now that we covered the solver and the editor a little bit, let's talk a little bit about the overall Nastran solvers. Now the Nastran solvers are much like the simulation mechanical solvers, cover a wide range of different analysis types. So we've enabled somewhere in the neighborhood of 6 to 7 different analysis types that are integrated into our workflows for setting up, solving, and reading results. But the Nastran solvers, they also support all these different linear and nonlinear pre-stress and buckling and transient heat transfer and all those different types of analyses as well. So this is the entire list of analysis types that we are not fully supporting through SimMech to run with Nastran solvers today. But these are things we are working on for our future releases to enable additional solver capabilities. Of course, if you just simply export your model to the editor, you can convert your input file to one of these different analysis types if you know the format of a Nastran input deck and then run those analyses. All right, so let's get into our CAD data support. From this point on, we are strictly talking about improvements to the simulation mechanical software. These are not specific to any Nastran workflows. This is true for all workflows. So what have we done in this release? When you're pushing a CAD geometry into simulation mechanical, the first question that comes up is choosing your analysis type. In this release, we have enabled the use of a default analysis type. So if you're always doing, for example, steady-state thermal heat transfer, you can set that as your default analysis type. That way, during the import, that question does not come up anymore. So then you can just simply proceed with setting up the analysis. And that really speeds up the import process because the question about choosing the analysis type would come up in the middle of that import process, and especially for large models, it would really break up the workflow. So now you can just set your default analysis type, and you wouldn't have to deal with that question from that point on. The other one was a common request from our user base, which is the ability to apply unique part colors, especially for inventor models. Whenever you're dealing with models that have the same material information, let's say everything is steel, inventor shows everything in the same color scheme. And when you send that model over to simulation mechanical, you would see everything in a gray color scheme. But for those of you who are dealing with large assemblies, you really want to be able to identify where one part begins and the other one ends. So we've added in the tools options to have a simulation scheme of color, which will give a different color to each part, which you will be able to identify it much easier. And of course, the big one in this list is we added a new CAD support. For those of you who are using Creo, you have now the ability to push models from Creo 2.0 to simulation mechanical. And also, this new workflow enables associativity between Creo and simulation mechanical too, which means if you send your model from Creo to Mech and mesh with certain settings and add materials and loads and boundary conditions and run it, and if you want to make a design change, you can go back to Creo and make that design change. And in the second time around, when you're pushing your second design change or the first design change into simulation mechanical, all those loads and boundary conditions and material information and the different mesh settings, they're all preserved, so you don't have to repeat all your setup. You just simply send your changed geometry into SimMech and simply hit analyze and get the results for the secondary design. And we already have this for things like SolidWorks and Pro-E and Inventor and a big list of different CAD packages, and in this release we've added the same type of interoperability with Creo 2.0. All right, so let's get into the meshing improvements. In the June release, we had the new mesh options for mid-plane meshes and plate shell meshes to use triangular only. So historically, we've only done mixed meshing for these planar objects, and in this release, we've enabled the triangular only mesh for those of you who were struggling maybe with our mixed mesh, or also with anything that is related to a Nastran solve. You really need triangular meshes on some of those planar objects. So we've enabled the triangular only option, so you can choose to mesh it triangular only. We've also in the June release added this application to apply a mesh refinement to a construction object. Historically, you could refine the mesh for a surface, for a part, for an edge, and you could also pick a existing mesh point and refine it. But in this release, you can pick a construction vertex, or as we call it in Inventor, a work point. You can add the refinement to be around that work point, and that really helps with the usability, because especially if you have complex shapes that you are looking at and you want to create a construction point in the center of gravity of it or something, you can do that using existing tools in SimMech, and then simply select that refinement construction point and apply a refinement point with a certain radius, effective radius, and a certain mesh size. But the big one that I really want to highlight, which I think is probably the biggest feature other than the Nastran interoperability, is the ability to remesh individual parts. So this improvement is very important if you're dealing with static stress and thermal analyses. So if for those of you who said, yes, I do static stress analyses, and for those of you who said thermal, you should probably give this a try. So when you're dealing with an assembly that has just more than one part, technically, if the default mesh is not to your liking, what do? You go back and you remesh your assembly. And historically, when you did remesh with a different mesh size or a different refinement or a different setting, simulation mechanical always meshed the entire assembly from start to finish. In this release, you have the ability to say, I only want one part to be remeshed, or I only want a select set of parts to be remeshed, instead of remeshing the entire assembly. And what this allows you to do, of course, is save time on those remeshing activities. But also it allows you to really zone in on how you want to remesh a given part and how you want the mesh matching between those two parts to be. Now, if you're doing static stress or if you're doing thermal, and if you want to consider bonded contact where two objects are going to touch, and if you remesh them individually, and if you don't pay attention to that contact setting, you will end up getting meshes that do not match on the boundary on where the contact is going to take place. So in those cases, you should go into the setup parameters and make sure you enabled what's called smart bonding, which will take care of the non-conformal mesh aspect and create the necessary contact for bonded and surface contact objects. All right, let's move on to the next one. Some improvements on usability. And some of this stuff was, like I said, already in the June release. We've just brought it into the August release. So the selection enhancement in the June release was the ability to use the what's called a neighbor selection. So it's this button that says More Neighbors. You can now select the surface after having meshed an object. You can select the surface, and you can just simply click More Neighbors, and it will, your selection set will grow so that you can easily select all these interior surfaces or all the exterior surfaces with just simply clicking the More Neighbors instead of graphically coming here and rotating the model and selecting all these intricate small surfaces around the fillets and rounds. This will really help for those of you who are dealing with pressure vessels or any kind of pump or fan design where you want to select all interior surfaces and assign an interior pressure. This will really help with the selection process. The way to use this, and I do have this model that I want to demo at the end, is to select all the capping surfaces, the surfaces that separate the interior and the exterior. Select those guys and turn the visibility off. And once the visibility of the capping surfaces is off, you select one interior surface, and then clicking the More Neighbors, your selection set will grow, and you will be able to select all these interior surfaces. We've also
that's pretty cool. That's a pretty cool new feature, actually. It's kind of like a seed and bound from Pro E, which I used to use.
That's exactly right, and we have some plans for the 2016 release to even improve that one step further, but we'll get into that later. The next couple are pretty straightforward. The selection groups, if you're not using this, you're missing out. Selection groups were introduced a couple releases ago, and what it is you can select either surfaces, vertex, lines, parts, anything that you can select. You can select in the FE editor, and once you have a couple of these selected, you can right-click and group them together, and it adds them to the list down here. And what we've done in this release is extended the support of what you can do with those groups. In the past, you could create those groups, turn on the visibility, turn them off, or add loads and boundary conditions. But now you can use those groups when you're defining surfaces for bolt interiors or joint interiors, or if you're trying to do a remote force, or if you want to create a centroid, or if you want to create contact elements, or if you want to select a bunch of points and move them together. So you can use them in a point move command. So basically now the selection groups, at least in the FE editor, are supported for everything that we can think of. So if there's more ways of using the selection groups that you guys need, please make sure to contact our tech support and let us know so we can improve the surface group, or rather selection group command to fit your needs. But I believe we're in a good position with selection groups for FE editor. Now, result interface does not support selection groups today, and that's something we're aware of and are working towards. The final thing is the check log access. So we have in the 2015 release added something called the output bar, which is not shown in this picture, but it's at the bottom of the interface. There's a mini dialog that you can turn the visibility on and off, and it always showed our solve log files and as well as output log files. We've added one more log file that you can choose from a drop-down called check log. So the check is what happens when you go to the analysis tab and hit check, or if you say solve, check happens automatically. And during that check, things like solid meshing happens, as well as we check for if there is any potential warnings or errors. And in the past, in the 2015 main release, you didn't really see those warnings and errors. If there was some problem, you didn't really know what was going on. So we've added the check log in there, so you can see the warnings or error messages and read about it and fix it before the running starts. What do you think? Should I pause for questions, or should I just continue? I only have a couple more slides. How are we on time?
So we did. We're doing really good in time. It's only half past the hour.
Okay. I'm sorry. Was there questions that I should answer that are related to some of this, or?
We did. We had a question from Pierre about maybe doing an example of the single part remeshing.
Oh, of course. Yeah.
At some point here.
Oh, yeah, I'll take care of that at the end of the PowerPoint. All right, so the next one is a couple usability improvements. And the big one here is, the top bullet point in the surface force application. In static stress or, linear or nonlinear, it doesn't really matter. In the past, if you selected 2 or more surfaces, and if you were adding a force, so let's say you're adding 100 Newton or 100 pound force to 2 surfaces. In the past, we would always add that 100 Newton or 100 pound force to each surface. So it would be 100 Newtons on surface 1 and 100 Newtons on surface 2. So the magnitude that you entered would be per surface. In this release, we've added a checkbox that says, hey, if I'm adding this 100 value to multiple surfaces, and in this case, this image is showing 3 surfaces, this 100 will be distributed to those 3 surfaces based on their surface area. So if these side surfaces are, for example, twice as much in area compared to this one, so it would be 2, 2, 1, it would be a 5 unitless surface area. Then what would happen is this 100 would be divided such that you would get 40 newtons here, 40 newtons here, and then 20 newtons here. And so it's just a good way of applying force to multiple surfaces. And the nice thing about all this is after you apply the load, the moment you hit OK, all of these loads and boundary conditions are listed in our tree view, right? So what you can do is you can expand this list, and you would see 3 objects. The first one would be for this guy, the second one would be for this surface, and the third one would be for this surface. And you can simply inquire or edit individual surface forces, and then you would see that it was actually adding 40 pounds or 40 newtons to this surface and 40 to this one and then 20 to this one, for example. So not only is the application easier, also the editing is pretty straightforward. And it groups them together, so you can simply, if you don't like the group, you can delete it with one swift delete key action. And the next one is just a simple reorganization. We've rearranged the browser commands. So if you are right-clicking on the element types and changing the element types, all the 3D objects are grouped together. There's a line separating 3D and 2D objects and then 1D objects. Same thing with contact types and different CAD mesh options. When you select the parts and right-click on it, you have some meshing options that are available there. We've simply rearranged them to make more sense in terms of how they're listed. Now you can also select multiple parts and rename them simultaneously. In the past, you would have to do this one at a time. And this is specifically useful for if you have, for example, 10 bolts that you want to rename them to the exact bolt size you're using. So then you don't have to do it one at a time. You can do it all at the same time. And the next one, for those of you who have been using simulation mechanical for more than a couple of years, you may have known this trick. But if you clicked on the parts heading and you pressed Shift-Control-M, the entire list of parts would collapse. And this was one of those hotkeys that only people in the know knew about. And we've added that same functionality into the right-click mouse, so you can collapse part details is now visible for those of you who are not, using SimMech day in and day out and may not be familiar with all of our hotkeys. So this will collapse all the part details and make the list much shorter with just a quick mouse click. All right, I think this is the last one. It's such a long list of improvements here. All right, this slide, obviously the highlight here is the Volt 2015 support. When we released 2015 Simulation Mechanical, we only supported up to 2014 version of Volt. The 2015 support was not fully implemented at that time. With one of our service packs, we improved it so that you can actually manage Simulation Mechanical 2015 files within your Volt client. But the Volt ribbon application within Simulation Mechanical 2015 never really talked to Volt 2015. So in this release, we've fixed all those issues, and we have full support for Volt 2015. And this we probably should have asked another survey question about data management, and if you are using Volt to do data management for CAD and SIM files, and that's something I would like to find out. Hopefully in our next hangout we can ask that question. But this you can now freely use Volt 2015 and Simulation Mechanical 2015 R1 together. And the last one is how we present our results. For our automated workflows, for our regular workflows, whenever you run a static stress or nonlinear stress analyses, you get your stress results and strain results in some formulation called smoothing. We always show you the average results from different elements, so you see results like this, where you don't see colors jumping from one element to the next. And that's what we do on our default results presentation. However, if you are using automated workflows such as global mesh refinement, and for those of you who have been using SimMech for the longest time, this was called Mesh Study Wizard, as well as something called Parametric Design Study, where you can change the parameters of an inventor file and do design studies on different designs, and to find the optimum stress, deformation, and weight for the part. If you are using one of these two automations, in this release, the graphs and tables that we do output from these two types of automations are now showing smooth results. So they're displaying results kind of like this in the table information and the graph information, so that the results that you're getting in those numbers match what you're seeing in the canvas for the results environment. So there's no discrepancy between what you're seeing and what you're getting in terms of numbers. And that is it. That is the entire PowerPoint I have. How do you get it? That's a common question that I keep hearing on different forums, is you just simply go to Subscription Center, go to Downloads, and download your product software. And when I put this presentation together, I was thinking that it would be called R1 on the Subcenter, but it is actually just simply called Simulation Mechanical 2015. You don't have to look for R1. What we've done is we're using the exact same link for 2015 in the Subcenter. We've just replaced the file that's behind the link. So now, when you just download 2015, you're actually downloading our R1 version. And if you have the April release of 2015, just simply uninstall that and install the August version, and you'll be good to go. Same licensing that you are using for 2015 will simply work for the August release as well. And that's it. So for the quick demo portion, I wanted to use this part that I had highlighted in the PowerPoint, and I'm going to go ahead and send this inventor file to Simulation Mechanical. Were there any other questions while this is coming up?
There were some other questions. There was one, we basically responded that certain solver features will probably be added over time from the Nastran. But this one was specifically about will we be integrating Nastran linear response and random vibration analysis capabilities? One that he's looking for is to plot absolute nodal response functions, and not just relative response to base input.
Yeah. So I think that's a good question, and that's one of the reasons why we did the poll in the beginning, to see what are the most common types of analyses, because we are looking to integrate more and more of Nastran solvers into Simulation Mechanical. So I can't really give any specifics about what's coming in the feature releases, but it is something we're working towards, to add more of the different linear dynamics types into Simulation Mechanical. So here's our model from Inventor, and let's maximize the mechanical and go ahead and create the mesh. And this is the important part, is to create a base style mesh to be able to use that neighbor command. All right, so now we have our base mesh. I don't necessarily care about the quality of the mesh. I'm just trying to highlight the ability to select these interior surfaces with ease. So I have all the capping surfaces that I can visually see. Oh, there's one more. I'm selecting them one by one. Looks like that's all. So I'll also highlight how to create a group. Now that I've selected those surfaces, and for those of you who are new to SimMech, I'm in the surface selection mode. I can right-click and say Selection Group, and I create a new group. So this is my Group 1. Let's rename it and call it Cap. Okay. What I'll do is I'll select that cap and turn its visibility off. So now the visibility is off. Let's go ahead and change our visual style to just shaded with edges. You're going to see that all those caps are turned off. I can select one of these interior surfaces and go into my Selection Expand section, and using the More Neighbors, I can just grow my selection, and I click a couple times until I see that it extends all the way to the edges of the design, and it did select all of them. I can now right-click and say Create a new group, and this will be my internals. Let's do it one more time for the externals. So let's say I want to select this guy. This is one of the external surfaces. I don't have to just select one, by the way. I can do a couple of them so that it grows from a couple different locations. So I've selected, in this case, 4 objects, and as I do more, you're going to see that it's going to grow from the original selection outwards. So I've selected all with a couple clicks. I can right-click and say Create a new group, and this will be my external surfaces. All right, so now I can simply isolate these things. If I isolate just the externals, these are all the external surfaces. If I highlight and select the internals and isolate those, these are all the internal surfaces. And you can kind of see why we did this. It's very difficult to select these types of small, intricate surfaces, especially when you have the external surfaces visible. Right? You need to really hide all those external surfaces one at a time to be able to come in here and select some of these intricate internal surfaces to be able to then apply a pressure or a force. And whereas with just a couple clicks, I was able to get all of them without even paying attention to what I was selecting. And another nice thing is you can see if you missed anything, right? So if you do this work and then you isolate it, you can come in and see if there are any gaps in your selection. And in the past, for example, if you forgot to select this little surface, let's hide it, you would have that little visual gap in there that would be very difficult to be able to identify that you didn't select that surface, and then maybe your simulation setup, your application of pressures skipped that surface, so you were actually analyzing this whole analysis with less force than you had to. All right, so and the final thing that's really useful in here is you can show everything, which is what I've done, right? So now I have every surface shown, and I'll turn the visibility off for all these groups to see what else is left that I didn't select. Looks like there are these bolt holes that I didn't select, and maybe it makes sense for me not to select them, or maybe it doesn't. And in this case, I'm not going to apply any pressures to those bolt holes, so it does make sense for me, not to group them together. But maybe while I'm in this interface, I may choose to come and select them and group them for maybe adding a bolt to them later. So, and the final thing you do, of course, is after doing all this work is to apply a pressure, and it's pretty straightforward. Let's go ahead and show all surfaces. And all you have to do is select the internal, go to Setup, and add pressure. There you go. I have my pressures added to all my internal surfaces. Or if I was adding a force, let's say I want to add 20,000 newtons. Do I want to add 20,000 to every surface, or do I want to distribute that 20,000 based on surface area? So let's say I want to distribute it to these 65 surfaces based on surface area. I hit OK. And what I do end up with is this group, and each surface gets a different magnitude. So in this case, that one got 1700, and this one got 2 newtons. It's all based on surface area. Any questions in this regard?
Did you ever do the remeshing?
I'm starting that right now.
Okay, great. Yeah, no questions on this. Just good feedback.
Let's pick a simple model. Yeah, let's pick this Pro E model.
So this might be a silly question, but is there a list, a public list that shows all like the general bug fixes for the service pack and R1?
So that's a good question. It's one that I'm struggling with personally as well. So the way for bug fixes specifically, the way it works is we only report the fixes for bugs in service packs. So if you Google and do Autodesk Simulation Mechanical 2015 SP1, so that's a service pack, and click here, you're going to see the README, and in the README, and I'm going to open the English one, you see all the things that we have fixed. So you're going to see that we fixed something like a program crash could occur when clicking the OK on the dialog option. So this was something that was broken in 2015. It is fixed in 2015 SP1. But we do not do this kind of reporting. Yeah, we do not do this kind of reporting for any major release. So if you're looking at what's fixed in 2015 or 2014 or 2015 R1, which is a major release for us, we do not actually list all the bugs, because in service packs, we fix anywhere from 10 to 50 bugs. So it's okay for us to be able to report those back. But in major releases, we try to fix a lot more than that. And therefore it becomes really difficult to report back on those. So for major releases like R1, we only, in presentations like this and in our reporting, we only highlight what's new as well as what we know is not working. So if you look at the README for R1, you're going to see the things that we know are broken in R1, but not the things that we have fixed per se.
Gotcha. And the R1, that's going to be available for the EDU community as well?
That's a good question. I believe so. I just don't know for sure.
Okay.
Yeah, I'll follow up on that one. If you can get the name of the person who's asking, we can do a follow-up on that one.
Definitely. Thank you.
All right, so here's a 4-part assembly, and we're just going to go ahead and generate the mesh. It's nothing super complicated, but I'm just trying to demonstrate the new improvement here. So here we have the 4-part assembly meshed, and let's say and let's give a dummy material quickly. Let's say they're all steel. All right, now we're good to go. And let's say we go to selection parts. Let's say this part I want to be able to remesh because it either failed to mesh, or I don't like the mesh, or I know that this mesh is not going to work for me because I need, let's say, 3 elements through the thickness or something like that. But I don't necessarily want to remesh the entire assembly. So what you do is you select all the parts and say collapse the details. So now you have this nice list, and you want to only mesh this guy. So what you do is you come here, you invert your selection, and then you right-click and say suppress. So all the other parts except for the part that you picked, or a couple parts you picked, for example, are suppressed. So now you can come in and say, I want to mesh this guy with let's say 40% of the mesh size. Right? So now I have 3 elements through the thickness. Right? And I'll even change the visualization to color using surfaces, so everything has its own surface color. All right, now I go back and unsuppress my original design. Okay? So you can clearly visually see that this part right here has a different mesh than this part right here. In the past, if I did this, I could do everything that I've done up until here, but I couldn't go and analyze this because the inputs just would not be acceptable to simulation mechanical. So let's say I add a surface channel constraint there, fixed. Let's say I add a pressure there, or a force there rather, let's say 1,000 pounds in the z direction. So in the past I couldn't run this analysis because the meshing would create a lot of headache for simulation mechanical. Now, I can run it right now using these settings, but the one thing that I highlighted, which is the thing that you really need to pay attention to in terms of contact, is what's happening to the mesh matching. Because I meshed it using different settings, you're going to see that I basically do not have any mesh matching between these 2 surfaces. And same thing is true for up here. I do not have good mesh matching between, the surface that's behind this one and this right here. So that means my bonded contact, which is the default, will not be actually honored for the simulation. And if I run this, these objects will just fly off in space. Or, this object is not tied to anything. So what you have to do, if you're using this technique to mesh, is you have to come into the parameters, you have to go to contact, and you have to say enable smart bonding contact. And you have some options here. You can do fine bonded to coarse bonded to fine, or fine bonded to coarse, and there's a lot of details. You can, if you click the help, you can read about what they mean. So in this case, let's try that one and go ahead and run this with simulation mechanical. And that smart bonding is only supported through simulation mechanical. We don't have that supporting through Nastran today. Just a heads up on that one too. All right, so the first thing it does is it creates the solid mesh, and this is what we're looking at. Is after it solid meshes, it converts all these lines into elements and creates our finite element model, and that's the check log. So if there was an issue, we would be able to see it here. And then the solve log is here, so you can scroll down and see that it's solved within this many minutes. And then our overall summary of everything as to where my files are saved and what it's doing, what unit system it's using, everything else is here. And before I could even show you those, the results are displayed, and you can play with the displacement exaggeration and see that for the object that has the good mesh versus the bad mesh, the results are very symmetric, that you're not seeing anything out of the norm. The deformations are symmetrical because the load is symmetrical, the contact is being honored, things are not flying off in space, which is why we have our displacement result as the first result that we show as the default result type. So you make sure that it is actually small displacement because this is static stress, and then you can look at things like Wamisi stress.
Yeah, so 2 things came in. One, can you just show which bonded type you use, the smart bond? I guess you went through that pretty quick, and I just want to see.
Sure, no problem. There are 2 options. I just picked the first one.
And then the other thing is, if you wanted to make sure that the mesh was actually matching,
yep.
So basically you have to remesh the other parts, what would be that quick workflow to kind of clean up the mesh, in other words?
That workflow is still valid. If you wanted to do it that way and have mesh matching, you kind of have to mesh everything at the same time. And the way to do that is you pick the part you want to remesh with a different mesh size, so it's this one. You come in here and you say, let's expand it. It has some mesh options for that specific part. You come in here and you say, you know what, don't use the mesh settings for the entire assembly, use specific mesh settings for that part. And you say, okay, the specific mesh settings are 40%, and the global mesh settings, which are the mesh settings that will impact the entire assembly, is 100%. So if you mesh it this way, this meshes the entire assembly all together as a group. But notice what happens is it also forces a finer mesh on this base part so that you have nice mesh matching between, actually let's do it this way. You have nice matching between this part and the base part, and you can visually see that the mesh is matching between those guys. Right? So this workflow is perfectly fine with the downside of creating all these extra elements that you may not necessarily care about. So it will take a little bit longer time to solve.
And
if you do it this way, of course, you don't need any of that. You don't need any of the smart bonding.
Right.
What you can do is you can visualize that contact grouping. Let me turn this off. And this may be probably something that very little, not a lot of people know about, is how to actually visualize that contact condition. Is in the Draw tab, we have this almost hidden option called Layer Control. If you activate it, we have, so every line has a part number, a surface number, and what's called a layer number. And we assign layer numbers to show different visualizations. For example, layer 14 are all the lines that show up on the edges of a CAD object. Layer 15, for example, are all the lines that are on a contact surface. So if I show layer 15 and show mesh visualization only and turn off these loads and boundary condition icons, you're going to see that between this part and let's say this part, so this part and this part, these two parts are contacting each other, and the contact interface looks like this. So I'll do that again.
Cool. I've actually never seen that before myself.
Yeah, you go to Draw. Of course, you have to have it meshed, right? Because we're looking at lines at this point. You go to Layer Control, and like I said, we assign specific layers, and you can read about what different layers means. But easy ones are 14 for edges and 15 for contact. 1 is all the internal lines. But I don't mean internal like into the solid. I mean on the surface itself, all the lines on the surface that are not on the edges or that are not on the contact, for example. And layer 2 would be mesh problems. So if you mesh something and it failed to mesh, all those regions that are giving you all the trouble would be automatically assigned to layer 2. I do recommend reading about those because you're not going to remember it from just watching this video. But the thing I'm highlighting here, of course, is the layer 15.
So we are at the top of the hour. It's not very common. We have the product manager here to answer questions. So I'm going to let it go for just probably a couple more minutes. But if you want to leave, of course, you're always welcome to do that. But here are just a couple more questions, and then we'll end the session. What about using mid-planes with smart bonding, no mesh matching? Is that something that you can work through and work? You probably can't do it here right now, but is that something that?
Yeah, I can show what they're asking for. I think can you read the question fully?
Yeah, it says completely. It's does this smart bonding, no mesh matching work on parts that are meshed with mid-shell elements?
I see. Okay.
Mid-plane shell elements.
Yeah. So let's take a look in that dialog quickly. So the answer is, before I give away the answer, I'm going to show everybody how to get benefit information in the future as well. So all I did is, somebody asked about smart bonding, so all I did is got into that interface and clicked the help button. And in the help section for 2015, it pushed me into the appropriate segment, analysis parameter, static stress nonlinear. So we're just going to right-click do like bonded contact search. So let's do smart. So this is the smart bonding. So these are all the things that are related to smart bonding. So I would read and find out about that specific question, and the answer is no, because smart bonding only works on solid objects. It does not work for plates. But this is how I would find out about such questions if I had them myself, and I do use the help because there's really no single person that knows everything about simulation mechanical.
Definitely.
Yeah.
Same with CFD. And then the very last question, then we'll end it, is in Draw, can you move specific nodes on a meshed model?
Of course. Yeah, that's very straightforward. So let me go ahead and show how to do that. So I'm going to go back and make sure that all the layers are activated so I'm not hiding any information. And let's say, and this is pretty common, let's say for this, let's isolate that object right there. And we're looking at this surface. Let's actually select the surface. This surface right here. And let's say I want to find out where the center of that surface is. And it's pretty common to be able to maybe add rotations or fix the center point. People often need to be able to find the center point for objects. So after selecting that surface, I go to I believe I go to Draw, and then I create a centroid. So when I do that, all I do is hit OK, and it creates that centroid for me. So let's isolate that surface. Okay. So now I'm looking at that surface, and there is a point that exists in the dead center of that. So let's say I wanted to move a point. I select a point, and let's say I want to move that point to the center. If I just go to Draw, Point Move, I can pick that point by left-clicking, and a mini arrow shows up. It's kind of difficult to see because my cursor is kind of covering it up. But you just simply, it auto-locks with a lock icon to any point that exists in the software. So there are no points here, so no lock icons come up. But if there's a point, it will lock. And if I wanted to move it here, I could do that as well. When I do this, a big, scary warning message will come up. It's basically telling me that if I'm moving points around on a CAD model, just be aware, you're no longer going to have the associativity. Right? You're going to be losing some of those CAD associativity workflows because now you're moving points around. You can't go back to your CAD and make an edit and come back and expect things to look the same. You're not going to be able to continue with all those associative workflows. You can still continue to load this up, mesh, add loads, boundary conditions, and analyze, but it will be a one-shot. It won't be a round-trip type of application. If you hit OK, all your mesh will auto-adjust. And of course, at this point, you're at the mercy of your own ability to create good elements, right? So, like, you have a nice rectangular-looking element here and a triangular-looking one, and all the node angles, at least on the surface, are looking somewhat 90 degrees. But because you moved something, you've made this 90-degree looking angle, let's say 120-degree looking angle, which is fine. But just be aware when you're moving things around that you're not degenerating your existing elements too much, right? So I've just moved that, and all the associated lines also moved. So when I hit Close and say View, Show All Surfaces, and let's zoom in there, you're going to have that moved object here. Just as a comparison, this is what it looked like before. I hope that answers the question.
Excellent. I believe it did. And with that, Suop, I really want to thank you for leading this presentation and everybody for joining. Just as a reminder, this will be up on YouTube within the next day or so if you would like to watch it again or just reference it in the future. And otherwise, thank you for joining. And again, next week we have simulation composites for our next Hangout session. Have a good day, everybody. Bye-bye.